Hello, my name is Ingo Moench from company FRABA. Today I would like to give you a brief introduction to innovative solutions from the fields of motion control, energy harvesting and IoT. My presentation will cover a technology for the generation of electrical energy on component level that is using a very special magnetic material, and I will share with you how this technology can help to innovate sensors from different fields such as IoT, but also including sensors from our own portfolio of position sensors, such as this tiny 22mm multi-turn encoder without battery for servo motors, or such as this very special solution for robotic systems. I will start my presentation with Wiegand technology for magnetic sensing, energy harvesting and IoT. This business is covered by our new brand UBITO, before coming in part 2 to motor feedback applications and in part 3 to position sensors for machines and AGVs. This business is covered by our traditional brand POSITAL. Wiegand technology can be used for magnetic sensing, but also for harvesting energy from a changing magnetic field. It can be used to trigger counters, but it can also be used to power electronics, including radio transmission. It has become the heartbeat of innovation for most of our products. There are certainly many energy harvesting technologies on the market, but Wiegand technology has its own unique characteristics. A change in an external magnetic field is converted by a Wiegand sensor into an electrical pulse. Very important, and here's also the difference to classical electrical generators. The energy of this pulse does not depend on the speed of change in the external magnetic field. And this unique feature makes Wiegand technology a very reliable power generator under all dynamic conditions. As it is a non-contact principle, there's also no mechanical wear and there's no reduction of energy over time or over billions of pulses. This technology and our production have a history since 1974, but during the last 15 years, many doors opened up to new fields of application. Multi-turn encoders were the first use case for our company regarding Wiegand technology. We became pioneer 15 years ago when we launched the world's first multi-turn encoder powered by Wiegand technology in year 2007. It replaced a gearbox technology that we used since 1973. So how does it actually work? There are two magnetic fields involved. One magnetic field is inside of this tiny little Wiegand sensor, which is in a fixed position within the encoder. And this field can only have two directions, up or down. A second magnetic field is generated by a permanent magnet that is attached to the shaft. And when the shaft is rotating, there is a tension being built up between the two magnetic fields, building up potential energy in the system. At a certain threshold reached at a certain angle, this potential energy is becoming so high that the field inside of the Wiegand sensor is suddenly flipping from up to down. And this is generating the electrical pulse that we need. With the power from this single pulse, we can boot the electronics, do the measurement, counting, and save the result into a non-volatile memory. We also use the timing and information from this pulse for the synchronization of single turn and multi-turn. As this is a non-contact principle, it also helped us to design encoders that are much more robust. They can be perfectly sealed and there's zero mechanical wear. Wiegand technology was first used for access cards to buildings since the 80s. It later started to conquer the market of water meters. It is also used in speed sensors for railways called tachometers. Furthermore, it can be used today in electrical pumps for intrinsically safe proximity sensors and for wireless power transmission, for example, through the skin into the human body. For this year, we are expecting a major breakthrough that will enable Wiegand technology to conquer a much larger market, the world of IoT. In a first demo, we were able to show that a single pulse generating event can generate enough electrical power to transmit information of 134 byte over a distance of 60 meters using ultra-wideband technology. The energy was also sufficient to power additional sensor elements for temperature, humidity, and pressure. We are very confident that vegan technology will be able to power wireless sensors as they are needed for condition monitoring and preventive maintenance in industrial IoT applications. The new design principle for rotary encoders using vegan technology also created new options how to design smart motor feedback solutions that can offer a multi-turn range without requiring a battery or gearbox technology. I would like to share two examples with you. First example, in 2020 we launched the world's smallest multi-turn encoder without battery. It has a diameter of 22 mm only and enables the design of much smaller actuators. As it's based on magnetic principles, it's insensitive to dust and moisture. It covers a very wide temperature range and is equipped with common open source electrical interfaces. Vegan technology allowed us to achieve a very small size while offering a very high reliability and performance level. Second example, vegan technology also allowed us to design multi-turn kit encoders without battery that have a space in the center of the encoder. And this space is very valuable when it comes to the design of robotic systems, especially collaborative robotic systems, where it's common to guide cables or compressed air within the arm of the robot where this product is installed. Size also matters in this application, and vegan technology allowed us to design a product that is more slim than other products without battery. All of our kit encoders can be installed in a normal factory environment as they are insensitive to dust and moisture. Complex or costly equipment is not required for the installation or calibration. In fact, our hollow shaft kit encoders don't require any calibration after the installation, and our 22 and 36 mm products come with an auto calibration feature that also makes additional equipment obsolete. All of our kit encoders are equipped with common open source electrical interfaces. What are proven applications for these products? Our kit encoders are used on stepping motors starting from size 22 mm up to 60 mm, and also on servo motors starting from size 40 mm up to 130 mm. According to our customers, more than half of these motors are used in AGB applications where they control the direction or the speed of the AGB. Other common applications include linear actuators or robotic systems, especially surgical robots or mobile robotic systems. Vegan technology has also enabled a lot of innovation within our large portfolio of position sensors for the machinery market and for AGVs. This portfolio includes inclinometers, also called IMU, industrial rotary encoders, and draw wire sensors. Inclinometers can be used in many different types of machines, especially in mobile machines or robotic systems. They are used to control the position and to monitor the stability for safety purposes. The general advantage of inclinometers is that they can be installed in any place within the machine because they don't have an interface to the actuator. They do their measurement with reference to the force of gravity. Within the field of inclinometers, dynamic inclinometers, also called IMU, have been by far the fastest growing technology. In case of dynamic inclinometers, gyroscopes are combined with accelerometers, and a sensor fusion algorithm is used to provide a stabilized output even under very dynamic conditions, as shown in this video from our exhibition booth. We are also offering a huge portfolio of industrial rotary encoders covering more than 600,000 different types with lots of electrical and mechanical interfaces. Most of them are programmable. Summarizing, our customers can choose among more than 1 million individual solutions for their individual application. Vegan technology has helped us to design multi-turn encoders that are much more compact, much more cost efficient, and much more robust. Today, our multi-turn encoders can survive severe shock and vibration up to 300 G, and they offer a protection class of up to IP69K. The mentioned industrial encoders can also be combined with draw wire adapters that convert them into linear sensors.
We offer more than 40,000 combinations, and they cover a measurement range from 1 meter to 15 meter, while offering a resolution of up to 2 microns. They cover lots of electrical interfaces and are also programmable. For applications with high safety requirements, we also offer combinations with redundant encoders. Just a few words about FRABA Group. Our group has its roots in Germany, and our products are still designed in Germany. However, we have a global product management team at 3 locations in New Jersey, United States, in Singapore and in Germany. We also have experienced sales consultants in 15 locations around the world. Furthermore, there are more than 200 certified distributors to service you. Our main factories are currently in Poland and in Malaysia. FRABA Group is using different brands for different businesses in different markets. Beyond the already presented position sensors and energy harvesting solutions, we also cover door automation and industrial transformation.
Thank you very much for your attention. If this presentation was interesting for you, please don't forget to follow us on our social media channels such as LinkedIn, WeChat or Facebook. Thank you so much.